Hi everyone, my name is Abramov. I'm going to talk about a library called Redux today. I already did that before, so I co-created Redux together with Andrew Clark. And Redux is a state management library that is often used with React, but also kind of popular in Angular community. And it combines the ideas of the Flux architecture by Facebook and the Elm architecture described by Evan Czaplicki, creator of the Elm language. And it has been a year since Redux was first released. The initial commit was exactly 1 year and 2 days ago. So happy birthday, Redux. To be honest, I never expected that it would become something more than an experiment, because it was meant to be an experiment in proving that hot reloading and time travel is possible if you make some tweaks to the Flux architecture. And I thought that everybody would forget about Redux in 2 months and it would be replaced by the next Flux framework of the month. So this did not happen for some reason. And this puzzled me because Redux downloads kept growing over the month of this year. And it has been downloaded over 3 million of times from NPM, which is a huge number for me personally. It's still 5 times less than LeftPad, but it is a lot for me. I never had a package this popular. And so in this talk, there's one more thing. Mobile Twitter is now using React, which is awesome for me because I use Twitter a lot, and it feels so humbling to be able to contribute back. It's amazing. The new mobile Twitter has amazing product experience, and so it's really cool that they're using it, and now I can use Twitter that uses Redux. So I've been wondering about what made Redux successful, and so in this talk I would like to reflect on the past of Redux and the present, and think about the future of Redux and why it came the way it is. So when I just started programming and I started using third-party libraries, I would evaluate libraries by their features and APIs. I would just pick the library with the most convincing bullet list and use this as my library of choice. But if you look at Redux, you won't really find many features there, because Redux is just an event emitter, a change emitter. There's just one single event, and it holds a single value. And if we look at the implementation, it's not rocket science either. We keep an array of all the listeners and the current state. We allow you to add a listener. We let you remove a listener. We'll let you read the current state. And if you want to change the state, you can dispatch an action. And we will call the function you provide with the current state and the action, reassign the state, and call all the listeners. And this is basically the core of Redux. This is the whole, it's not exact implementation, but it's pretty close to what Redux provides. And so definitely people are not choosing Redux because of its features and APIs, because there are no features. So as I thought about it some more, I realized that I no longer think about libraries strictly in terms of their features and APIs, because when you just start in any kind of creative field, you only notice the things that are immediately visible. And these are the features and APIs for libraries. Just like a musician might think that a melody consists just of the notes. But as they become a better musician, they realize that the pauses between the notes are just as important because they create the rhythm. And an architect might think about an architecture as exterior and interior of the building. But as they become a better architect, they realize that the value of architecture is the space that the building creates for the people to live and work in. And so I think the visible side of the libraries are the features and APIs, but there is also the invisible side, which is the constraints and contracts. Constraints are, I'll make it a bit larger. Constraints are the limitations that you as a library author artificially place onto your users. You say you can't do certain things, but I'm going to give you something in return. And if you know Redux, it enforces a bunch of constraints. First of all, that the state of your app is described as an object tree, just plain objects arrays, no custom models. The second constraint is that if you want to change something, there are no setters. You need to dispatch an action describing what changed. and an action is also a plain object. And third, to implement the update logic, you write a special function called reducer, which is a pure function that takes the state and action as arguments and returns the next state. And it sounds pretty limiting, but there are some benefits. For example, Redux has a very specific debug workflow. You can log every action and the state because there are plain objects, because every mutation has an action associated with it. And so look, you can log every action and the state, and if you see something bad rendered in the UI, you can check when the state became incorrect by going through the log and finding the place where the mistake happened. And because the action is a plain object and is designed to be human readable, you can check how the action looks. And if you see something like type follow user ID nan, you know that it's probably the problem is in the component. So you go to the component and fix the problem. However, if the action looks fine, you know for a fact where exactly the bug is. Because for every piece of the state, there is a reducer function corresponding to that piece of the state and how it updates. So you can open the corresponding reducer, you can find the corresponding switch case for the action, and you know for a fact that this is the place where the bug is. And as a bonus, you can write a test because it's easy to test reducers as they are pure functions. So you don't need a browser, you don't need to render your app, you don't need to mark anything. You just call a function and assert that it returns a certain value with certain arguments. There is also another set of benefits that comes from the fact that everything is data. Both state and actions are objects. And so objects are easy to persist. You can just take your state and convert it to JSON stringify, put it somewhere, and then when you want to resume your app from the same point, you load it and JSON parse, and there you have it. The same works for universal rendering, because you can take the state on the server, you can do some data fetching to prepare the store, then you can JSON stringify it, pass it to the client with the HTML, and boot up the client from the same state. You can also do error reporting much more nicely, because you know that all mutations happen through a centralized point, so you can put a try-catch around it. And if you catch an error, you can send the state and the action as a payload with the error report, so that you can reproduce the user session. And you can even record a series of user actions, so you can go step by step through what was happening. It is also possible to implement optimistic mutations because we're not mutating the data. So if you want to display some kind of, like the user followed another user, we want to display it immediately, and later, if the server tells us that the request failed, we want to roll back, we can have an action queue in memory that contains this optimistic action. But if we're sure that this did not succeed, we can just remove it from the memory and recalculate the current state as if this action never happened. It is also easier to implement collaborative editing because the actions are already plain objects, and so you can pass them through the network. So as you see, Redux enforces some constraints, but constraints turn out to be just as important as features because some constraints give you some features in return, and I learned that it's important to think about both when you're designing a library. Redux also offers some contracts, and contracts are like the other side of the APIs. Contracts are the APIs that the user implements. These are the APIs that you don't provide as a library. And there are some contracts in Redux, such as reducers, selectors, middleware, and enhancers. And you might use some of them and not use the others. So the contracts that you use while you develop the app, I'm going to mention the reducers, which is the way to specify how the state updates. And reducers are interesting because reducers are composable. So a reducer called todos can call a to-do reducer to figure out how an individual to-do is updated without knowing its state shape and its implementation details. Composability is very important. There are also selectors, and this is not a core concept in Redux, but I've come to appreciate it more as I looked at real-world Redux apps. And basically, if you ever wrote a map state to props function, this is a selector. Selector is just a thing that takes the state, takes some optional arguments, and returns some kind of derived state that is more useful to the UI. Here's an example of a selector. It's a getVisibleToDo's function that takes the state, the filter, and returns the to-dos filtered by this filter. It turns out that it's very useful to group reducer and selectors, and this is something I don't see people do very often, so I want to promote this pattern. The idea is that you collocate the reducer together with selectors operating on the same state shape in a single file. And the benefit of this is that, for example, the state is an array, but what if I want to store some additional information there? Well, all the code dependent on the fact that it is an array lives in this file. So if I change the state shape, I just need to change this single file. I don't need to go to other components or other reducer files. There are also some contracts that you don't usually implement. However, it's important that they exist. For example, higher order reducers are functions that take your reducer as an argument, take some additional arguments, and they return another reducer. And if you're familiar with higher order components in React, this is kind of the same pattern, but for reducers. Here is an example of a higher order reducer called Undoable that augments your reducer with a logic to keep track of the undo stack. So you can implement undo and redo with any kind of data. The way it works is that it keeps track of the present value, which corresponds to what the user sees, and all the past values. To calculate the present, it will call your reducer, so it doesn't need to know how your state is organized. It will work with any Redux reducer. But it also keeps track of the past, and anytime an action is dispatched, it adds a new entry to the past. This way, when you emit an undo action, it's going to return the present that it takes from the last past value, thus going back in time. And it is entirely decoupled from any specific implementation details of your reducer. So it can be published on NPM and work in any Redux app. And in fact, it exists on NPM. This particular higher order reducer is called Redux Undo. There is another higher order reducer which implements the action queue so that you can put the actions as if they happened, but you can later remove them if the server gives you a negative response. Another higher order reducer called Redux Form wraps your model reducer where you specify how the model is updated, but enhances it with the fields tracking the pristine or dirty values of the form, whether it has any validation errors, and so on. So it's a very generic pattern, and you can implement many different things with it. Another Redux ecosystem contract is the middleware. And middleware lets you add custom behavior to the dispatch function of Redux. By default, Redux just allows you to dispatch plain object actions. But we can teach Redux to dispatch promises or to log every dispatch that happens in the system. The way this works is the promise middleware will get the action object. And if it's not really an object but a promise, it is going to wait for the promise to complete before passing it to the next dispatch function. The next dispatch function is the function of the logger middleware. And logger takes the action, logs the previous action in the state, which is really convenient to see in the console, and calls the next dispatch function, which, if it's the last middleware in chain, will just call store dispatch. And then we can log the next state. And as you can see, these functions are completely independent. They can be published on NPM as well and be community packages. So the first middleware is Redux Logger. This is pretty much similar to the one I showed you, but it's more configurable. There is another cool new middleware called Redux Observable by folks from Netflix that lets you implement complex asynchronous action creators using RxJS5 observables. There is also a new project called the Polar Client, which I'm very enthusiastic about it. It's like it's a client for GraphQL, and it's still very early stage. It's like maybe 5% of what Relay does, but it's a cool community project, and I'd like to see more people contribute to it. The final contract that is the most powerful in the Redux ecosystem are enhancers. And these are functions that create store, that is like a store constructor, and return the function with the same signature. And this is kind of similar to the inheritance pattern in classic object-oriented programming, because you can override anything in the behavior, but because these are functions, they are composable, so you can apply multiple enhancers. For example, this enhancer lets you debounce the calls to the subscribers. So if you dispatch many actions in a row, they are going to be debounced, and the subscribers are only going to be called once. There is an enhancer that implements Elm architecture in JavaScript, which lets you return side effects from reducers, which is more functional than some people like, but it's cool that people have this kind of way of doing it with vanilla Redux and this enhancer. And there is a cool project called Redux DevTools extension, which takes Redux DevTools, but places them in a remote client. And this DevTools extension enhancer hooks into Redux dispatches and communicates with remote client, so you can have a debug view of what's happening with Redux in your IDE or a Chrome extension panel. So my takeaway from this, what I learned from this, is that contracts need to be designed as carefully as the APIs, because they are just as important for the ecosystem. So here is what I learned building and maintaining Redux. You need to design holistically. Don't just design APIs and features. Think about constraints that you put and the contracts that you provide to the users. Make constraints useful. Don't just decide that we're going to disallow it for no reason. You need to have a good rationale for why you're disallowing things and what you provide to the user instead. Make contracts social. If you have holes in your API that you allow people to fill, make sure they are composable so that different people can create different extensions to your system and use them together. Design the way out of the paradigm. It's really cool that Redux is a single store, but sometimes it doesn't work well. Well, you don't have to use Redux, but you can still use Redux contracts if you'd like to. For an example, here is a React component, and it doesn't use Redux. But notice that it calls a reducer function. You can use your reducer functions in your component together with setState, the local React state paradigm, because reducer is just a function that returns the next state. It doesn't care if it's used inside or outside Redux. Find the useful stress tests. This was really important for me. Last year, when I presented Redux, the stress tests that I used were autoloading and time travel. While these are amazing features by themselves, the main thing I learned is that they were a proxy for other constraints that turned out to be important for other useful features. So if you design a library, find the good stress tests that will help you guide your design and evaluate which decisions to take. If any new features is proposed to Redux, I think, does it work with autoloading and time travel? And not just because those are important, but because they turn out to be a very useful proxy for other important features. Market good ideas. There are a lot of good ideas out there. There are a lot of good ideas in JavaScript ecosystem, Clojure script ecosystem, Elm ecosystem. I said it at the last conference. You saw that it worked for me. It will work for you. Find the good ideas, promote them, create documentation around them, create examples around them, because it is just going to come back to you. It is awesome. And I thought, while Redux does not provide you many features, and it can be a downside, some people like that it gives them deeper understanding of what's happening in the system. Because what I heard from a lot of people is that they used these libraries and they did not understand at all what was happening inside of them. So if you can't provide a lot of good features, at least provide some good understanding of what's happening in your library. Of course, Redux is going through a lot of hype. And it doesn't really deserve all the hype that it gets. So be careful. I'm not proposing that if you're starting a React project, it doesn't mean you need to take Redux and throw it into it and for every feature write an action creator, reducer, selector. This is just crazy. So be constrained. I suggest you to learn Redux, but don't take it too seriously. Just if you see that if you have a lot of cached data and your state tree does not neatly map to component tree, maybe it's a good time to introduce Redux. But don't do it because of the hype or because I told you. There are many libraries that actually provide features. So I encourage you to look at those libraries and not just Redux. Check out Relay, RxJS, React, Mobex, Cerebral. These are awesome libraries and they do a lot of things for you. So maybe if you don't want to build your own architecture, it might be a better fit for your project. Redux is kind of tricking you because it gives you the promise that it gives you all these amazing features, but what really happens is that you end up building your own architecture. And some people like it, and some people don't like spending too much time on it. And it's okay, it's a trade-off that Redux provides. But the reason I think Redux is successful is because people who value understanding their systems completely, and people who like building architectures, they use the social contracts provided by Redux to build their apps and share their solutions to their problems. And so Redux has a rich ecosystem of solutions thanks to these people. If you ask me about the future of Redux, the way I think about it is it's a small stepping stone to the immutable app architecture, which is a much bigger concept. And if you'd like to learn more about it, I suggest you to watch Lee Barron's talk at RenderConf 2016. It's really inspiring, and it paints a cohesive picture of how immutable app architecture allows us to deliver great user and developer experience. So the future of Redux is not Redux itself, but rather a cohesive story about declarative data fetching, like in Relay, built-in optimistic mutations, kind of like Relay 2, easy to test async control flow, like Redux Saga or Redux Observable, combining local and server data, I'm not sure I have a good solution to this, and great developer experience, which is something that Redux tries to provide, but there are much better ways to do it, and Mobex and Cerebral also provide great developer tools. So I think that what we as a community need to work on is creating this cohesive story, and we can create it around Redux or without Redux, and it doesn't matter to me. But if you create something that solves some of these problems on top of Redux, I welcome you to contribute, because this is how we build the cohesive story around the mutable app architecture. And Redux started as an experiment. It was an experiment for me and an experiment for Andrew, but it grew out of this. And I think it is still an experiment, but it's not my or Andrew's experiment anymore. Because right now, this is your experiment, and I'm excited to see what you build with Redux. And there's one more thing. This is the new ACAD series that I've been working on for the past month. It contains 27 new videos. It covers topics such as using Redux together with ReactEurope, with Ajax, persistence. So check it out. It's free, and I actually need to publish it because it's not there yet. So Joel told me that I can press publish now. Hopefully it's going to appear very soon. Thank you so much. Do we do any Q&A? We can do a little Q&A if anybody has questions. Question? Yeah, so the idea is that middleware processes actions one by one. I mean, the middleware chain contains different middlewares, and they pass the actions to each other. So the promise middleware sees the promise, it waits for the promise to resolve, and when the promise resolves to an action object, it will pass that action object to the logger middleware. So you will only see the result objects that will get into the reducers in the log. But I think it would be awesome if somebody built a promise logger middleware that would stand before the promise middleware and that would log the currently active promises, for example. Any more questions? Question? Yeah, so the question is the stress test. Did the time travel and hot loading come before coming up with the Redux, or did I just, yeah. So when I proposed a talk to ReactEurope last year, I had no idea how to implement time travel or how to load in with Flux. So I wanted to speak about how to load in React because I was really excited about it, but I had no idea how to do it with Flux. And I thought that if I just submit a talk about hot loading, nobody would want to see it because it's like everybody saw it before. So I just added and time travel to my talk description, and I had to figure out how to implement time travel. So to be honest, yeah, these stress tests, they came before. But when I saw the first benefits that are unrelated to them, I realized that I should use them as the guiding principles. And it can be hard to discover the guiding principles, but once you discover them, I suggest you just go ahead and use them all the time. Any more questions? That's it. Okay, thank you very much. Have a good conference.